Hey there, science fans! Are you ready to embark on a journey through the intriguing world of numbers and patterns? Bill Nye here, and today we're diving into the fascinating world of statistics. Statistics isn't just about numbers. It's about understanding the stories they tell us. Get ready to explore a cool idea called the Central Limit Theorem, or CLT for short. This theorem is a cornerstone of statistics and helps us make sense of large sets of data. Don't let the big words scare you. It's all about patterns and surprises with numbers. The CLT shows us that no matter the original distribution, the averages of samples will form a normal distribution. Imagine you have a giant jar of jelly beans, but you don't know how many are inside. It seems like an impossible task to count them all, right? How could you get a good guess without counting every single one? By taking a few samples and using the CLT, you can estimate the total number with surprising accuracy. That's where the CLT comes in handy. It allows us to make educated guesses about large populations based on smaller samples. It helps us understand how groups of numbers behave and how to make smart guesses about big groups of data. This is incredibly useful in fields like science, economics, and even everyday life. Get ready for some dice rolling fun as we unlock the secrets of the CLT together. By the end of this, you'll see how powerful and exciting statistics can be. Let's dive in and explore the magic of numbers. Let's start simple with a single die. We all know it has 6 sides, numbered 1 through 6. If you roll it many times, you'll notice that each number has an equal chance of showing up. It's like a fair lottery for numbers. We can graph our results, showing how often each number appears. With one die, our graph will be flat because each number has the same chance. It's like a level playing field for our dicey contestants. But what happens when we add more dice to the mix? Hold on to your hats because things are about to get interesting. Now let's grab another die and roll them both together. Notice how the dynamics change when we introduce a second die into the mix. What do you think will happen to our results? Will the outcomes be predictable, or will they surprise us? Will it be the same as rolling one die, just twice as many rolls? Or will the combination of 2 dice create a new pattern altogether? Not so fast. This time, we're adding the numbers on both dice. This simple addition changes everything. Suddenly, some totals become more likely than others. The distribution of sums isn't uniform anymore. For example, there are more ways to get a 7, 1 plus 6, 2 plus 5, 3 plus 4, than a 2, only 1 plus 1. This is because the number of combinations that result in a 7 is higher. Our graph starts to change shape. It's not flat anymore. Instead, it forms a triangular distribution, peaking in the middle. The middle numbers, like 6 and 7, start to bunch up, while the extreme numbers, like 2 and 12, are less common. This is because there are fewer combinations that result in the extreme numbers. This new shape gives us a clue about how groups of numbers behave differently than single numbers. The bell curve we see is a fundamental concept in statistics. Intrigued? Let's keep rolling and see what other patterns emerge. Ready for more dice rolling action? This time, let's use 5 dice and see what happens to our graph. Remember, we're still adding up the numbers on all the dice for each roll. As we roll our 5 dice over and over, a fascinating pattern emerges. The middle numbers become even more common, while the extreme numbers become even rarer. Our graph starts to resemble a bell shape, with a rounded top and sloping sides. This bell shape is starting to look familiar, isn't it? It's a sneak peek at a very important shape in statistics, the normal distribution. But we're not quite there yet. Let's roll with 10 dice and see what happens. Section 5, 10 dice. Tell a tale, the bell curve emerges. Get ready for the grand finale. We're rolling 10 dice now and adding up the numbers for each roll. Can you guess what our graph will look like? You guessed it. The bell shape becomes even more pronounced with 10 dice. The middle numbers are very common, while the extreme numbers are extremely rare. We've created a beautiful bell curve, also known as a normal distribution. This bell curve isn't just a pretty shape, it's a powerful tool for understanding data. and the central limit theorem helps us understand why it appears. Section 6. The normal distribution, a statistician's best friend. The normal distribution is like a roadmap for statisticians. It provides a clear and predictable pattern that helps in making sense of complex data. It tells us how likely different values are to occur in a dataset. This is crucial for making predictions and understanding the underlying trends in the data. Many things in nature and in our daily lives follow this bell-shaped pattern. From the heights of people to the weights of fruits, the normal distribution is everywhere. For example, if we measured the height of everyone in a large school, we'd likely see a normal distribution. This means most students would have heights around the average, with fewer students being extremely tall or extremely short. Most people would be close to the average height, with fewer people at the very tall and very short ends of the spectrum. This pattern helps in understanding the spread and central tendency of the data. The central limit theorem, or CLT, helps us connect the dots between our simple dice rolls and these real-world examples. It shows how even random events can form a predictable pattern when looked at in large numbers. It tells us that when we take many samples and calculate their averages, those averages will start to form a normal distribution, even if the original data wasn't normally distributed. This is a powerful concept because it allows statisticians to make inferences about populations from sample data. Understanding the normal distribution and the central limit theorem is essential for anyone working with data. It provides the foundation for many statistical methods and helps in making informed decisions based on data analysis. So, whether you're analyzing business trends, conducting scientific research, or just trying to understand the world around you, the normal distribution is truly a statistician's best friend. Section 7. Why does sample size matter? The bigger the better. Remember how our bell curve became clearer as we added more dice? That's because sample size matters. The larger our sample size, the closer our results will resemble a normal distribution. Think of it like this. If you only ask a few people their favorite ice cream flavor, you might get a skewed result. But if you ask hundreds of people, you'll get a much better idea of the true distribution of ice cream preferences. The CLT tells us that with larger samples, we can be more confident that our sample average is a good representation of the true population average. Section 8. Real-world wonders, CLT in action. The central limit theorem isn't just a theoretical concept, it has real-world applications in various fields. For example, scientists use the CLT to analyze experimental data, pollsters use it to predict election results, and quality control specialists use it to ensure product consistency. By understanding the CLT, we can make better decisions based on data and gain valuable insights into the world around us. Section 9. From dice to data, unlocking the power of CLT. So there you have it. We started with simple dice rolls and uncovered a fundamental principle of statistics, the central limit theorem. We learned that the CLT helps us understand how groups of numbers behave. As sample size increases, the distribution of sample averages approaches a normal distribution. The normal distribution is a powerful tool for analyzing data and making inferences. The CLT empowers us to make sense of data, from understanding scientific discoveries to making informed decisions in our daily lives. Section 10. Keep exploring. The adventure continues. Congratulations, science explorers! You've journeyed into the world of the central limit theorem and emerged with a newfound appreciation for the power of statistics. But the adventure doesn't end here. There's always more to learn and discover in the fascinating realm of numbers and data. So keep asking questions, keep exploring, and keep the spirit of scientific inquiry alive. Until next time, stay curious.